Okay, let's have a look here. So the next one, let's see, I've got a picture here. This one here, 20, yeah, we're on 29. Okay, so for 29, I'll just write this. Question 29. So domain and range. Domain looks like it's all real numbers, assuming this extends outwards. Range is all the positive numbers, including 0. The x-intercept, plus or minus 1. The y-intercept, just 1. When is the function increasing? Decreasing, increasing. So don't know if we want to necessarily include minus 1. Minus 1 to 0, and then 1 to infinity. When is the function decreasing? Minus infinity to minus 1. And then 0 to 1. Okay. The interval for which the function is constant. No interval. Symmetry about any axis and or the origin. Yeah, it's symmetric through the y-axis. And that's about it. And is the function even, odd, or neither? It is even. Symmetric, so it's even here. Okay, so it's okay. Let me check how they gave the answers here, since I do have them. So all real numbers greater than or equal to 0, plus or minus 1, 1, minus 1 to 0, and 1 to infinity, minus infinity to minus 1, and 0 to 1, null, through the y-axis, and even. Yep, we are a-okay with that. Let's have a look at question 30 now. Okay. Domain. All real numbers again. Range. Minus infinity to 3. X-intercept. Oh. How am I supposed to judge where that is? Why did they do this? A quarter and 0.25 or 3.75. Y-intercept, minus 1. Increasing from minus infinity to 2. Decreasing 2 to infinity. Constant, nowhere. Any symmetry? Through the line here, y equals 2. And it's neither even nor odd. Yeah. Oh, I said y equals 2. X equals 2. X equals 2. Okay. R looks okay. Minus infinity to 3. 0.25 and 3.75. Intercept at -1. Minus infinity to 2. Decreasing. Constant. Symmetry. Axis to neither. Yep, okay. Okay, that's question 30 done. Now on to 31. Okay, so I think this time these do look like asymptotes. I don't think this is supposed to extend up to infinity. I know what graph that is. I recognize it, but for people who don't recognize it, you know, where is this upper limit here? I'll tell you in a moment. The domain, it's all real numbers, and the range is actually minus pi over 2 to pi over 2. But if you didn't recognize this graph, how on earth are you supposed to know that? I wonder what they say in the answer. They go with 1.5. Yeah, 1.5 is fine. Actually, 1.57. So I guess they don't expect students to be pinpoint precise here, which is good. I'll just put a little, that's the real answer. But, you know, it's okay to say minus 1.5 to 1.5. X-intercept. X-intercept is just at 0. Y-intercept, also at 0. The function is increasing everywhere and decreasing never. And the constant never. And it's symmetric through the x-axis. Oh, no, it's not. It is not. Not symmetric through the x or y axis, but through the origin, which makes it an odd function when it's symmetric through the origin. And I just confirm the answers. Yep. All real numbers, not decreasing, not constant, origin and odd. Yep, okay, that's good. Let's have a look at 32 now. Quick one, not a function, because it fails the vertical line test. E.g., one maps to 1 and -1 as an example. Okay, 33. Domain looks like all real numbers. Range is only from -2 to 2. -2 to 2. X-intercept and Y-intercept are both 0. It's increasing from -2 to 2. Decreasing never. Constant? up to -2. And it's also constant, but a different constant from 2 to infinity. So 2 to infinity. It says the intervals, which is making me think maybe I shouldn't really have the union symbol in these answers, instead just separate them with a comma. So in the previous answers too, maybe a comma would be more appropriate than the union symbol. But maybe I shouldn't sweat too much about these little things. Symmetry, it's through the origin, which makes it odd. Yeah. Well, what's really important is consistency. So even though now I'm doubting whether I should have had the union symbol in it, it's important to be consistent. So I'll go back to writing the union symbol. I thought from looking at the answers, commas would have been better, but let's not stress about them. Okay, so that's 33. Oh, and I have the answers for 33. Yep. 0, 0, -2 to 2. Not decreasing. And. Oh, the answers do say and, so I could use the. No, the union symbol is usually for or. Oh well. Origin and odd. Okay. Next one now. 34. 34. Domain, all real numbers. Range, 0 to infinity. X-intercept, 0. But the y-intercept, oh, this is... Oh, sorry, the x-intercept just cross it at 0, but then all the negatives as well. So I want to be a little bit fancy and say x, all values of x where x is less than or equal to 0 is an intercept. And the y-intercept, that's definitely only 0. Function is increasing from 0 to infinity, decreasing never, constant from -infinity to 0. No symmetry, and neither even nor odd. Ooh, that's kind of a tricky one. X-intercept, y-intercept, increasing, decreasing, constant. Yeah, okay. And unfortunately that answer's not at the back. So I'll never know for certain. Okay, and then 35. Oh, I'm still thinking about that union. It's and in probability. And I need to stop thinking about it. All right, 35. Okay. Domain is from -4 to 4, including the 4 because of the little shaded dot here. The range is also -4 to 4. X-intercept at some unknown point, 1.2, I'm going to say. What did they go with at the back? Oh, 1.2. Lucky me. Okay, and then y-intercept is 4. Increasing never. decreasing 0 to 4, constant -4 to 0, symmetry none, neither. See if I'm right. -4 to 4, -4 to 4, 1.24, not increasing, 0 to 4, -4 to 0, none, none. Yep. Okay, for each of the following exercises, find each pair of functions. For each pair of functions, find sum, difference, product, and division. Okay, let's have a look. So, sum, difference, product, and division. Okay, so let's add them together. 3x plus 4 plus x minus 2. That's equal to, oh, which question is this? 36. That's equal to 4x plus 2. So the function f plus g of x is equal to 4x plus 2. Okay, that will be 3x plus 4 minus x plus 2. That would be 2x plus 6. So the function f minus g of x is 2x plus 6. F times g means it's 3x plus 4 times x minus 2, which will equal 3x squared. And then we'll have 4x minus 6x minus 2x minus 8. So that means fg multiply. Now, I'd better put the dot in to not confuse it with compose. F times g of x is 3x squared minus 2x minus 8. F over g, that's 3x plus 4 over x minus 2. Well, that's it. So that means f over g function of x is 3x plus 4 over x minus 2. Okay, no answer for that one. So now 37. Okay, so it's x minus 8 plus 5x squared. That's equal to 5x squared plus x minus 8, which means the function f plus g of x equals 5x squared plus x minus 8. Then the subtraction. So that's nearly the same, 5x squared plus x minus 8. So that means the function f minus g of x equals minus 5x squared plus x minus 8. The product, that will equal 5x cubed minus 40x squared. So that means f times g of x equals 5x cubed minus 40x squared. And then lastly, x minus 8 over 5x squared. So that means the function f over g of x equals x minus 8 over 5x squared. Okay, we can check this answer. 37. Yep. 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 And yep. Oh, and you know what? I must have missed something here. It says determine the domain of each of these functions. So for this question, the domain is all real numbers for 1, 2, and 3, but not for the last one. For the last one, the domain would be all real numbers except for 0, of course. Now, I wonder if I can go back in time to the previous question, if it's still in my history. Let's hope I can go all the way back. Yeah, that's good. So here, again, something similar. The domain for the first 3 is all real numbers, but not for this one. The domain is all real numbers except for 2. Yeah. So we're okay now. Find f plus g, f minus g, f g, and f over g. Determine the domain of each of these. Yeah, okay, so we've got the domain then. Okay, so I think we'll leave it for there. Next time we'll pick it up from 38. No. Yes, 38 then. So if we got a few more, quite a few more actually, with the functions. And then onto the calculator technology-based questions. All right, that's good. That's good for today.